Rotations. So we're continuing our discussion of rotations. We're going to talk about rotations around a vertex today. So we've talked about rotations around the origin, where we're looking at the center of where our axes meet. So that's one way that you can rotate a figure. And remember, when the figure rotates, it changes its direction. So it kind of moves along the page. It doesn't flip over like a reflection. But it kind of rotates around like it's on the hands of a clock. So yes, we talked previously about rotating around the origin as our center of rotation. Today we're going to talk about rotating around a point. Typically we're going to have you work around one of the corners of the shape, but it could be a random point in the middle of your coordinate plane. So let's take a look at what we've got here. The vertices of a triangle are J12, K14, and L44. Rotate the triangle 180 degrees about vertex J. What are the coordinates of the image? So when we rotate, we typically want to know three pieces of information. What's our center of rotation? We want to know which direction are we going, and we want to know how far. Notice that in this one, I've actually only given you two pieces of information, 180 degrees around vertex J. So vertex J is going to be the center of our rotation here. And as you've probably already discovered, if we're rotating something 180 degrees, we don't need to know the direction. So 180 degrees would go from like 12 o'clock to 6 o'clock on the hands of our clock. So if we go clockwise or counterclockwise, 180 degrees we will end up at 6 o'clock. So it doesn't matter which direction we go. So you may not see direction with 180 degrees. Totally fine. All right, so what I'm going to do is I'm going to grab my piece of patty paper here. And I've already traced out my shape on my coordinate plane. So here's my JKL on my coordinate plane. So we want 180 degrees around vertex J. So vertex J is going to stay the same. So I already know that vertex J, when I'm done with it, is going to be 1, 2. It's not moving. It's going to stay exactly the same. All right, so I'm going to go 90 degrees, and again, doesn't matter which direction I'm going. Again, J is staying right on top of itself. I apologize for you looking at the back of my head while I'm rotating here. And then we're going to go another 90 degrees, so that we're at 180 degrees. We're upside down. So notice J is still right on top of J, and I'm going to take my new ordered pairs from here. So K, you'll notice K and L were at the top of my figure before. Now they're at the bottom since I've gone 180 degrees. So K is now down here at 1, 0. So K is at 1, 0. You could write this right on your patty paper if you wanted. And L is over here at -2, 0. -2, 0. And I have a picture here. I have an idea of what my image should look like once I've moved it. K and L should kind of be the bottom of this shape. J should be kind of an upper corner on the right. So I'm going to get rid of my patty paper, and I'm going to draw this shape. So J is at 1, 2. That's right where it was. It's not moving. K is at 1, 0. So here is my K. So it came straight down. So here is K prime. Oh, these are all primes now. I need to label them primes. And this one was L prime. And then L prime is at -2, 0. So -2, 0. Here is my L prime. And I'm going to connect those sides so that I get my new shape. So here's my rotated shape down here. It's still congruent to the original shape. So we have corresponding angles, we have corresponding sides. Those are all still congruent to each other. I've just rotated around like this was the center of my clock. Okay, so rotating around the origin, around a vertex, very similar to rotating around the origin, except we're not going to draw that our axes on there, and we're just going to worry about that one vertex as far as the center of our rotation.